we welcome you all once again for the day 3 of Skill Elevation Club program, Students Capability Enhancement program on data science. This is day 3. Today we are going to have a lot of hands-on excellent section is going to be given by Mr. Arvind on behalf of the management, institution and department. I cordially welcome Arvind for day 3 of this 1 week National Students Level Capability Enhancement Program and Data Science. And I also cordially welcome all the participants from various institutions, faculty members from other institutions, and faculty members from our own department. So with this, I would like to invite Mr. Arvind to take over the session. Arvind, you can continue.
Yes, sir. Yeah.
Thank you.
So, okay. So hi everyone. Welcome to day 3, and today we are going to see some interesting concepts like natural language processing. And I told you yesterday to look at naive bias, and I hope that some of you might have understand what it says. And those concepts come under conditional probability, and so the base for naive bias is conditional probability and Bayes rule or Bayes theorem. We'll look at those things today, and we'll get started with the data set like yesterday, and we'll go through step by step of pre-processing and applying the naive bias and do all those stuff today. Okay, today what we are going to see is we are going to see multinomial naive bias. So that's what we are going to do. I'm just going to introduce about those concepts, and please bear with me today for some more minutes, because it's going to be a somewhat theory, because you can understand it better by seeing what the base of naive bias and conditional probability. Okay, we'll get started. Before getting started, okay, I would like to introduce about some basic concepts about probability. Let me just give you some introduction of probability and conditional probability. Let's see probability. Okay, so you all know about probability, I think, because there are lots and lots of examples like flipping a coin, rolling a dice, or events, like whether the event can occur or even cannot occur, those kind of things. Those things give you the probability. For example, if you flip a coin, it will give you a probability of getting a head. The probability of getting a head is 0.5, and the probability of getting a tail is 0.5. So the total probability is going to be 1. So that's basic probability. Okay, let me somewhat let's touch upon the conditional probability thing. Okay, so what is a conditional probability? A conditional probability will give you if there is a I'll just show you rather than tell you, because okay. So for example, so what is a conditional probability? So this is a basic denotation, you can say. Probability of A given B, that is a probability of A intersection B over probability of B. So this is a somewhat basic formula for conditional probability. And if you see the, let me see if there is some example. Okay, suppose let D1 is the value of roll of die 1 and D2 be the value of roll down die 2. Probability of D1 is 2. So if you see this table, you can see the sample sizes. And if you see this, the second one, probability of D1 plus D2 is less than 5. And the table D1 plus D2 less than 5 for exactly 10 to 36 outcomes. That is probability of D1 plus D2 less than or equal to 5 is equal to 10 by 36. So in this is a sample space. So you will get to know about sample spaces, and the expected values, the variance, and everything about probability when you learn about probability and statistics, about discrete random variables and continuous random variables. So you will get to know about the sample space and all. So if you can see that this thing as 10 by 36, because if you roll 2 dice, that will give you 36. So that's what we are doing over here. So if here if you can see that the event 1A is D1 equal to 2, so the D1 plus D2 less than 5. So if we compute this, so we already see the formula for probability of A given B equal to probability of A intersection B over probability of B. So that is the probability of 3 by 36 over 10 over 36 equal to 3 over 10. So this is what the conditional probability of A given B. So this is somewhat basic about conditional probability. So let's get somewhat more into probably some Bayes theorem, and we'll move on to naive Bayes classifier. So this is the basic knowledge that you need to know about conditional probability. Let's go to Bayes theorem. So this is Bayes theorem. So what Bayes theorem says is, for example, we need to calculate the probability of A given B. So if you see in the previous one, the formula is probability of A intersection B divided by probability of B. So that's what the basic conditional probability is. So what the Bayes theorem tells us is another way of calculating probability of A given B. So if the probability of B given A is given for our problem. So this is the basic notion of probability of A given B for using Bayes theorem. So which is equal to probability of B given A, product of probability of B given A and probability of A divided by probability of B. So this is so what you need to know about this is this is the Bayes theorem. Bayes theorem that we need to know for calculating probabilities using Bayes theorem. You will just get to know about all these when you learn about probability. Let's see a basic example. This might be a best example. Okay, so if we take drug testing, excuse me. Just give me a minute. Okay, let's proceed with it. If we take the drug testing, you can see that probability of user given positive. That is, for example, if you can take a disease, for example, or the true positive and true negative. So that's what we are doing over here. So in this example, the probability that someone is a drug user is given by that they are test positive. So let's see what's the probability using Bayes rule. So probability of user that is given positive. So this is what we are testing, whether the person has consumed drugs or not. So that's what we are doing over here. So probability of user given positive equal to probability of positive given user into probability of user divided by probability of positive. In this problem, we have already given all the information that we need to calculate the probability of user given positive. So what is the probability of user given positive? The probability of user will test positive will be given using this, using the solution given. So let's see how we do that. So probability of positive given user. So we are just expanding the formula over here. And then we are inputting the inputs that there is already in this data. and then we are getting the output as 19%. I think you might have get some basic idea of Bayes theorem, because trust me, it is somewhat vague in terms of explaining, because you need to just work on some problems in order to get familiarized with this. So just for this workshop sake, for this presentation sake, just you need to know about this basics. So let's proceed with naive Bayes classifier. Okay, let's see the probabilistic model. Okay, so I think it is somewhat complex over here. So let's crack on what is given in this complex formula over here. Okay, let me just zoom in. Okay, so this is what multinomial naive Bayes. This is what we are going to work with today. Let's see what is given over here. So the probability of x given Ck. So k will be the multinomials of multi-class case. So and then which is equal to summation of I equal to 1 to n. So this is x of xi. So the x are the feature vectors, and the I is from I to n. So the n will be the number, and over product of I equal to 1 equal to n xi factorial. So both are we're just using the factorial over here, and the next term is the product of I equal to 1 to n, and with the pi, which is the multinomial that is generated by the certain events, and to the power of x of I. So so you can see that it's somewhat a complex formula. Let's see how it translates into our problem, and how we classify things, because it's somewhat a complex one, because there is lots and lots of notations, lots of I equal to n, I to n, I to n. So it's just like going like a distribution of some kind. So we'll see how it is processed. So let's get on with our problem of NLP today. So what is NLP, and how NLP can so how NLP can work with text data and produce a classification output. That's what we're going to see today. So why naive Bayes is very useful for text classification is there is an application for email processing. So there are lots and lots of spam emails around in the world. So if some email comes into our Gmail inbox, let's see how it is classified. So this is how it's classifying it as a spam or not spam email. That's where naive Bayes is used. Still, it's used today for classifying emails, which is spam or which is not spam. So it's a basic model. So it is very easy to implement and get started. So that's why I'm just using naive Bayes today, and we are just using the text classification today. Okay, let's see the data first, because I think visualizing it in Excel, it's somewhat good. Okay, so today the data set that we deal with is IMDb review data set. So what is IMDb, Internet Movie Database? Some of you might have known about that website. So there will be information about all the movies, and you get some reviews. So and you can view how the movie is performing. So that's what the website is. So this is the reviews from that website, and we can see that there is lots and lots of text data over here. It's a long review. I think you might be familiar with yesterday's thing about taking the data and doing all the visualization and everything. So this is also another data, and the label, which is giving us whether the review is positive or negative. So that's what we are going to classify today. So we are going to classify whether the review is negative or positive. So if the reviews are more negative, more on the negative side, then the movie is not performing. If the reviews are more on the positive side, then the movie is performing well. There might be some bias that it might be a paid review, but for the sake of this problem, we just assume that every review is genuine, and we'll proceed with that. So let's see how many data are there. We can see that there is almost like 100, I think, yeah, 100,000 data are there. And the classification, that is a label is which is negative and positive. There are both labels. So there is also a label called unsupplied. We don't need that. If you see the data over here, so there is a unsupplied data over here. So we don't need that. We need to eliminate that. Let's go through the problem. Okay, let me import some header files. I think I explained what is header files and what we are doing with it yesterday. Let's import the data set. Okay, let's explore the data set. So we already explored the data set in Excel, but for seeing whether our problem is reading the things correct, there we just visualize it in our worksheet. So that's what I'm doing over here. Okay, I want to ask you one thing. So how do you like process a data? So take the first sentence, for example. So how do you process this data? So what can be done to take all the data and process it? If you can, if someone has any idea, just tell me so that we can proceed with that. Just tell me what tells that the first sentence is a negative review. Let me show you the data set. Okay, this is the old data set. Okay, let's go over there. Let me copy this. Okay, I think this is the review. So can anyone say why this review is a negative one? So how can we deduce the review which is a negative one? So segregate it into parts of speech for each word. Yeah, that can be done, but so what tells that this review is not a positive one? That's what I'm saying. What you will do? Not just don't tell me in the perspective of the computer. I'm just asking you about your perspective. So why do you think this review is a negative one? Someone having any ideas? So why this review is a negative one? Okay, we can watch for negative words. Yeah, that's a good sign. That can be a good one because there is a negative ones and positive words over here. Any other ideas? Okay, because he's trying to explain about the mistakes in the movie. Yeah, that's also a good one. Yeah, basically we'll just what we do is we just make the machine learn. So okay, let me proceed with it because I think some of you have some basic idea what we are trying to do over here. Let me just go through it so you can have some more insight of what I'm doing over here and how we are just taking and doing the classification for this data set. If you see over here, the data set over here is a review. Normally what we do with the data set is we just pre-process it. Like the project previously that we dealt with, we are just going to pre-process the data. So what can be done to the pre-processing? Okay, let me just explain you with this sentence. If you can see that there are lots of full stop over here, we can take that. So we can also take the apostrophe s. So this is not needed. So we can take all the of, the, for, commas, of, which, the, everything can be taken out because it doesn't tell anything about the movie. It's just used for stitching the sentences together. So what we are going to do is we are just going to remove all the unnecessary things so that it gets narrowed down to the words, to just words that describe about this classification. Let's see how that is done. I'll just show you the process when we do with each and individual thing. Let me just do the stemming. It will take some time because the review is a large data set. So it's almost like 50,000 data. So it will take some time for it to process. So let's wait for that to complete. So that's why it's taking some time. So the Python kernel is busy. Let's wait for it to complete. Because NLP problems are very computer intensive and it needs to work a lot for doing the pre-processing. So that's why it's taking some time than our previous data set. Because the previous data set deals with only a few data, like 1460 data. But this has some 50,000 data. So it takes some time for it to process. Let's wait for the system to finish the processing. I'll show you the data once it's done with the pre-processing, because after that you will be able to see what's happened after the pre-processing, after the lemmatization and stemming. So those two are the important process for natural language processing. So we'll see how it is done after this running. Let's wait. Because it normally takes this long to run. So that's why I'm just waiting for it to complete everything. Okay, so it's done with the processing. Let's do the same for the test data. Let's wait for it to run. Okay. You can see that before we'll just compare the records now before it starts. Okay, so you can see the first sentence over here. It starts with story of a man who has unnatural feelings for. Okay, let's see after the lemmatization and stemming. So you can see that the story, the spelling has been modified from STORY to STORI of a man who has, it took all obviously the yes, and unnatural feeling for. So what we are doing is we are just replacing some n words, and we are just changing some n words. That's what we are doing with the lemmatization and stemming. So it has its positives and it has its negatives. So what I'm doing over here is I'm just using I just test the performance of the naive bias. If I'm not happy with it, I'll reduce the lemmatization and stemming, because in some ways it produces a better result by not doing the lemmatization and stem. For in the first case, I'm just testing whether it is producing a better result or not. That's what I'm just exploring now. Let's complete that. Let's just wait for it to complete, because there is a lots and lots of data. As you can see that my CPU usage is full high. Let's wait for it to complete. This is like programming. Yeah, obviously it's the basic is for you to understand what is data and how the data is like you can process and get the insight of the data. It's not like you program something and get the output. It's just we need to understand about the data. Yeah, that's what we are doing over here. So which you want to see the paragraph, scroll up. Okay, I'll show you the paragraph. So this is the paragraph. You want to see this, or can you be more specific of what you need to see? Okay, I think that answers your question. Let me proceed with the next step. So I'll just come back for your questions after I finish with this. Then after pre-processing the data, I'll answer your questions like yesterday, and then I'll proceed with the model and everything, naive bias. Okay, let's see the sentiment. So this is what the sentiment distribution is. So the sentiment, I've said the sentiment is positive and negative, right? So I'm just seeing how many data which is positive and which is negative. So you can see that it has the equal distribution. Like that is almost like 12,000 for the negative and almost 12,000 for the positive. Let's see the word cloud of what's a stoppers and every other things, and that is in the data. Okay, so you can see that these are the words that we need to see in the word cloud. So there is a break statement, make, think, movie, and all this is just like viewing what are the words that are much more prevalent in the data set. Okay, let's okay, so we are going for the naive bias. Okay, let me answer some questions and then I'll proceed with the naive bias. Okay. So if you have any questions about our data pre-processing until now, I just did some basic pre-processing than yesterday, because yesterday's problem needs some more pre-processing than this. But this data set is somewhat like a clean one. We just need to eliminate the unnecessary things, and we need to do the necessary things. So that's also a nice thing. Okay, I'll answer some questions. Just ask me if you have any questions. Let's because if you don't know what we done up to now, then you need to ask me any questions, because you won't understand the model and what it is doing in the further sections. Because in this problem, data pre-processing, we will do it inside our model also. So what I'm doing over here is I'm just using custom multinomial base, multinomial naive bias in this. So yeah, you will see that one. Yeah, if you have any questions, just post it in the chat, so I'll answer that before proceeding to the model, because it will be somewhat complex that we follow all the things that are in the formula that I've shown in the start. Yeah, we'll go through that together. Yeah, just type if you have any questions. Okay. Okay, so how does Python narrow down the sentence by excluding words like of and so? Okay, so there is packages called NLTK packages. So that has stop words and lemmatization words and stemming words. Just see, I'll just type the package name. NLTK. So this is the package name. You can browse, and it has all the words and everything that you need to process. Yeah, so those things will identify the words and remove it. So the packages is like functions, like what we use in C and C++, like iostream.h. So that's what having all the stop words and everything. Yeah. Okay, I'll wait for like 5 more minutes so that you can ask any questions. We can proceed after 5 minutes. This data includes a specific or all programming language. I don't get, I don't know what you mean by all programming language. Are you asking me that we can process the data using any other programming language other than Python? If you are asking me if you can process with any other language, then you can, but it will be a lengthy process. If you can see that what I'm doing over here is I'm achieving all the stop words and pre-processing using 10 lines. But if you want to program a custom stemming and lemmatization using C and C++, it will take almost like 100 or 2200 lines, sorry, 200 lines maybe, for processing the lemmatization and stemming. So each will have like 100 to 200 lines of code. It is achievable, but it will take a lot of time to do that. Yeah. Yeah, Python is easier. Yeah, that's what I'm trying to tell you in detail, because you can achieve that in any language. Okay, let's proceed with the model, and we'll see the multinomial naive bias. Okay, let's answer the another question. Does NLTK classify the words? It provides you the library of words, but you need to program your program so that it eliminates the words from the sentences. So that's what you need to do basically. Yeah. So NLTK provide the words that you need to classify. Sorry, you need to take the things out of it. Okay, let's see the naive bias. So this is where we get into the classification thing. Okay, so let's initialize the tokenizer. Let's get with the naive bias. Okay, let me just explain this program in simple terms, because I think this is what we are basically doing over here, and we are expanding it like this, and we are just doing it like this. Let's see how it is done. So the Laplace smoothing. So this is what we use to just like smooth the things. We'll see in the fit method of the classifier. If you're familiarized with C and C++, sorry, not C, C++, there is a concept called class in C++ and Java also. So you can define a class, and you can define a function inside a class. And if you initialize the class, and you can call the functions. So that's what we are doing over here. We are just defining a class called naive bias, and I'm just using the initializer. So these two things will initialize once we declare this class as a new instance. And these are all the functions that are inside the class. You can see the functions until predict. So the function which says the group class, what it will do is it will take the X and Y, and it will group it into a class. And let's get to the Laplace smoothing after the fit, because this method is used over here. Let's see the fit method. So these are all the variables that we need for defining this. And the group data, we just grouping the data over here, and we'll take the group data and we initialize it in a loop. And for the C and log class peers. So if you can see this, we are taking the log. So that's what I'm doing over here. Math.log self class items C over length of X. So that's what over here. So length of X. So let's go through the next one. So you initialize a for loop inside that, and we'll just tokenize the text. So what it does is it will split the sentences into words, and it will take the count. So what the count basically does is it will just count the items. So that's what it is doing. So after that, I'm just implementing the for loop inside that for loop, and you can see that I'm just incrementing the like appending the list of self counts over here. So that's what I'm doing over here. So once this fit class is done, we'll just go for the predict. So this class, this function will return us the class that that is predicted using the data that is given. So this is what the main thing. Okay, let's see the result. We are declaring a list, and like the previous, we are just doing the same, and we are just initializing some variables over here, like log class peers and self classes. So everything will be declared over here, over in the initial init function. And So we'll just take the words, and for words and words, if the words is not in self vocabulary, and it will just I'm just looping into the classes, and I'm just doing the Laplace smoothing with the word on the C, that is a class name, and the class course will be incremented and the results will be appended. So I think it is somewhat complex thing, because it is very hard for me to explain, because without getting into the data, and without like experimenting it with, it is difficult for me to explain to. Okay, let's take the next thing, and we'll see how it is working. So I think you might have lots and lots of questions about naive bias, but if you look at the classifier over here, and if you just like deduce everything from this, then you will get to know what the function is doing, because it's very hard for me to explain, because without there is any data, and because it does a lots and lots of things inside. Because if you see this, it will take the words, and it will just convert into numbers, and it will calculate the what is that, calculate the scores, and it will give the classes. So that's what it's doing basically. Let's go to the predictor. Okay. What I'm doing over here is, I'm just, yesterday I've told you, like some problems don't deal properly with text data. So in this also, we just made our model to accept only classes that have that is in the numerical form. So that's what I'm doing over here. I'm just using the label encoder like the previous exercise. So we converted the text into labels. That's what I'm doing over here. You can see the encoded data. Okay, let's execute this. Okay, you can see the labels over here. Let me correct this to a single line. Okay. Okay, so the classes are over here, because the 0 and 1s are the classes, and the tokenizer, I'm just initializing the tokenizer, and I'm fitting the X train and Y train. Yesterday I told you about splitting the data, and the test sizes I'm using is I'm using a 80-20 split over here. So this is what I'm just using for the test size. I'm fitting the data over here. Let's fit the data. Let's fit the data, because as I told you before, it takes a lot of time and computing resources for doing natural language processing, because it takes a lot of time, because there is huge data and it needs to deal with everything. Okay, let's predict it. So in case you're wondering whether it is doing a perfect thing, like we declared the class over here. This is the same thing as naive bias over here. And the classes and tokenizer we need for the tokenizer and the classes over here. And the fit function is over here. It is fitting the X and Y. So that's what I'm doing over here. Let's go to the predict function. So the predict function calls the function over here for the class that we declared. Let's as I told you before, the accuracy doesn't matter, because if the model is too accurate, then it's not doing its work properly. The accuracy should be near 1 but not 1. So that's what we need. So we have an accuracy score of 0.8532. There are also another ways of deciding whether our model is performing properly or not. That is the confusion matrix. Let's see what the confusion matrix is. Okay, let's print the classification report, and let's go with the confusion matrix. Let me program the confusion matrix and print the confusion matrix. Okay, you can see the confusion matrix over here. Let me just visualize it in some fancy way, so it will be very clear of what the actual sentiment and the predicted sentiment is. Okay, so what this confusion matrix is showing us. So what this confusion matrix is showing us is, for example, if the value is negative, then the predicted value, so this is true positive, this is false positive, sorry, this is true negative, false negative, this is false positive, and true positive. So this is what we are seeing over here. If you can see that our model is predicting the classes with the negative values as negative. So it is classifying 2027 records as negative, and it is making some mistake by classifying the negative statements as positives also, because there is 488 reviews. It is classifying it as a positive, but the actual review is negative. So this is why our predictor has an accuracy of 0.85, and the positive, it is detecting 246 sentences as negative, and the original classes, the original statement is a positive one, and our predictor is predicting 2239 statements as positive, which is a positive. So these two parameters should be very high, and these two parameters, that is a false negative and false positive, should be lower. So this is how we can determine that our model is classifying things properly. That's what we are doing over here. Let's go to the precision and recall score and F1 score. So I've already we have already saw the R2 score yesterday for the regression model. In classification, we decide that our model is doing our model performance is based on the precision, recall, and the F1 score. Let's so all these things should be high, because the precision and recall score should be high, the F1 score should be high. So let's see the test data. So we have two data. One we have is a trained data, and another one is the test data. Let me show you in the Excel sheet. You can see in the IMDb master, there is a in the type, you can see that there is a test data. And if you scroll down, you can see there is also training data. So what we done until now is we split this training data into two and evaluated our model. So what we need to do now is we need to test on the test data. So this data is never seen by the model. Like it don't know what the data that we are giving. If it performs very beautifully on this test data, then we can conclude that our model is doing an excellent job. So this is one type of natural language processing that you can do. Yeah, let's see the test data now. So what I'm doing is I'm declaring the test data over here, and I'm just converting the label like I did with the previous training data. Okay. Okay. I'll just do with the predict thing. Because I just missed a variable name. So Let's predict it. Let's wait for the predictor to complete. Because this test set is a huge one, like it's near the size of the training data. Okay, it's finished now. Let's see the classification reports. Let's see the confusion matrix, the precision, recall, the F1 score. Let's see the confusion matrix over here. So you can see, as you can see, that these two are highest, and the diagonals in this to the false negative and the false positive is lower. So we can conclude now that our model is performing beautifully, and let's we check the accuracy score. It's almost 0.82. It's a nice score, but we can improve that by much more using the pre-processing techniques that we done. Like we can remove the lemmatization and stemming, and we can check also. And you can test with the pre-processing. There are lots of pre-processing techniques, like you can do the you can convert all the words to the lowercase. You can remove punctuations. You can remove lots and lots of other things. And you can just manage the data. You can like mold the data to get more accuracy score. What I'm doing over here is I'm just using naive bias. We can also do with another classifier like logistic regression, decision tree classifier, and other techniques. Yeah, so there are lots and lots of other classification techniques that you can use to get a better score. Okay, I think we explained the natural language processing over today now, but I think it's somewhat theoretical rather than some more practical, I think. Like, yeah. So if you have any doubts, just ask me about what we are doing, the confusion matrix thing, and it is somewhat like this is the basic thing what we do with data pre-processing and the natural language processing. So what, okay, I'll just give you some overview of what's that Google Assistant is doing. Okay, let's take Google Assistant, for example, and what it is doing. If you take Google Assistant and make it to predict what you're saying, so what it does is it takes all the words that you say and form it into a sentence. So the sentence that you just give it to the Google Assistant will be like this. So it takes all the sentence, and it is having a classification thing. So it is having a huge classifier model like this. Like this is a simple classifier model that I've showed you for classifying between positive and negative. So it is having a huge classifying model. So for example, you are asking what is the weather now. So what it will do is it will take the words. So let me just what is the weather now? So what it will do is, let me zoom in. So basically what it does is, so it will remove all this thing. So it will remove all this thing. So it has weather now. So what it does is it has a huge classification thing. So we are predicting whether the sentence is positive or negative. It will classify it as weather now class, and return the current weather. So this is what it's doing. So there is a class that is called weather now. So when the predictor hits the weather now, it returns the current weather. So that's what it's doing. This is how Google Assistant or Google Now, it's doing its natural language processing thing and giving you the response that you need. So it doesn't matter that you say what is the weather now or weather now in my place. So it doesn't matter. So what it will remove the weather now place. So weather now, it will just it will also just like remove the words like weather and now. So that's pretty much how Google Assistant works. You can deduce that natural language processing thing is working with Google now and all the virtual assistants like Amazon Echo or iPhone Siri or the Microsoft Cortana or every other virtual assistant over there will do this thing, like this natural language processing. Okay, so I think I think you get some basic idea of what natural language processing now is, and I think it will help you. I think it inspired you to know about natural language processing and how it is done. So this is what basically natural language processing is. It's not like a fancy term. We do the same things like for the linear regression, for the natural language processing. The data pre-processing technique is different. The model implementation, the prediction is everything the same, and we evaluate the predictor like the same. So this is what the basically natural language processing is. There will be somewhat much more advanced and deep things like RNN, recurrent neural networks, and there is also vectorizing. If you can explore that, there is a concept called what is that? TF-IDF vector. That is term frequency inverse document vector. So that it's another concept. So you can explore that also for natural language processing. And yeah, that's pretty much it. That's there is also another one also. You can explore like aspect term based natural language processing. So that's another concept. Yeah, this is pretty much what we do in natural language processing. So I think I've explained it somewhat clearly, but I think it's somewhat vague for you. But yeah, I think you get a basic idea by now. Yeah, if you have any questions, just post it in the chat and I'll answer the question. Okay. NLP is easier or tough? It depends. It depends on the problem that you work with, because there are lots and lots of problems that has in that you need to do NLP, and it depends on the problem. For example, there is a problem if you want to review all the if you want to process all the reviews for a product, for a company. For example, if there is a company that sells computers, and you have to gather all the reviews that are written for that computer, whether it is good or bad, and if you want to classify whether the good comments and bad comments. So that's how the problems differ from place to place. Yeah, it depends on the data that you collect. Yeah, if you have any questions about the problems that we worked out or anything, just post it. I'll reiterate if you don't understand anything about how we interpret all those things. I'll wait for another 15 minutes for you to ask any questions.
Students, you can clarify your doubts and post your questions in the chat box.
Okay, there is another question. Just a minute. For log function, is there any separate header files? Yeah, you need a header file called math. If you see the program that I've implemented in it, it has a class called math.log. So that's the package you need to include. Yeah. Okay. Okay, the basic idea of NLP is to sort the prefixes and suffixes of words accordingly. Please correct if I am wrong. It depends. As I said before, it depends. It can also include fixing the prefixes and suffixes. If you want to increase the accuracy of the model, then you can include, you can just fix the prefixes and suffixes. The basic thing, what I'm doing over here is I'm just removing the stopped words. I'm just using the stemming, like it's like not fixing the suffixes. It's more advanced than that, if you ask me. Yeah, that's what stemming and lemmatization is doing. Yeah, there is more pre-processing techniques than doing the prefixes and suffixes. If you see that there is another method which will find the aspect term. The aspect term will find the relationships between the words in the sentence. For example, there will be adjectives, there will be noun, there will be verb. There is another conjunctions and other relationships between the words. You can also explore that, and you can also place it in a classifier like naive Bayes, and you can predict the classes by that way also, because that way will be somewhat more it will be more accurate than the method that I'm using, because I'm just using the simple, like taking the words as tokenizing the words and putting into the classifier and predicting the thing. Yeah, for you to understand it simple, I'm just keeping it with the basic program, because if I go with the aspect term and if I go with the relative relations between the words in the sentence, it will be somewhat hard for you to understand. Yeah, there are so many methods that you can do with the pre-processing techniques. Yeah. I think that answers your question. Yeah, any other questions? Okay. 10 more minutes is there. So if anyone has any questions, or if anyone needs to know where you can explore more, then just post it so I can answer it.
Students, you can unmute if you want. You can unmute and ask, or you can put your queries in the chat box. Thank you.
The programs like Python, C++ are used in which fields? There are variety of use cases for C++ and Python. Most of the Windows operating system kernel is programmed in C++, and Linux kernel is basically programmed in C, and all the things that is the kernel of Android operating system is programmed in C++. So if you see traffic controllers and other things, it is programmed in C. Traffic controllers, I mean the signals that you see in the road, it is programmed in C. So there are lots and lots of use cases for programming languages. In Python, you can program like websites using, I don't know the package name. You can program websites. There is a, the package name is Flask. You can use that and program a website using Python. You can use Python for data science. So there are lots and lots of other uses for Python. Yeah. So it's a high-level programming language. So it's a very useful programming language to use in a variety of fields. Yeah. So should I use Jupyter or can I use other text editor to work out? Jupyter Notebooks or Jupyter Lab is the best thing, because you can't use any other editor. Because if you use VS Code or anything, yeah, the program obviously runs, but for viewing information and doing all those things, Jupyter Notebooks is the best thing, because trust me, it's somewhat jerky to start with, yeah, but you will get used to it, because it's very easy for you to visualize all the things that you write. Yeah, basically Jupyter Notebooks or Jupyter Lab is the best thing. Yeah. Yeah, you can use Google Colab also, but it's based on Jupyter Notebooks. So both are same, if you ask me. If you can use Google Colab, there is a thing in IBM also, I guess, IBM Cloud. There is also another thing in Azure. I don't know the name because I don't use it. So there are lots and lots of cloud implementation of Jupyter. Yeah. You can use either of them. Okay, there is 5 more minutes. You can post any questions. Okay, so I think you get some overview of what is done and everything. Yeah. So let me just. Okay. 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 Okay, I think that's the end of my session today. So I think tomorrow the session will be handled by Mr. Ramar. Okay, so thank you for providing the opportunity to speak with you all. I think you got some insight of what data science is, and I think I given you some inspiration to get started. Okay, thank you everyone. So yeah.
Thank you. Students, your feedback form is posted in the chat box. The feedback link will be available for another 5 minutes. I take immense pleasure in extending my sincere thanks to the management for conducting programs like this for the betterment of students, even in the pandemic situation. The department has been doing a lot of events for students upliftment. This is another program. I thank Mr. Aravind for sharing his wonderful time. Despite of his busy schedule, accepted his invitation and presented a wonderful session. Thank you, Aravind, on behalf of the institution management department. I thank the students, participants from various schools and colleges, and as well as faculty members from other institutions for showing the interest in this program. I thank the members of staff from MCA department for their wonderful cooperation in making this function a grand success. So day 3 program as usual went on well. We have the 4 more days to go. I request all the participants to attend the event in full and make sure that at the end of the 7th day, you become ready for developing a simple application or a project using this event. Thank you. Thank you, Arvind.
Thank you, sir. Thank you. Thank you for SRM Institute of Science and Technology. Thank you.
Students, the feedback link is available in the chat box. You can submit your feedback. Sudha madam?
Yes, sir.
We'll wait for 5 minutes, madam.
Okay, sir.
5 minutes. Let them submit the feedback.
Okay.
And